Hello everyone and welcome back to the channel. If you are new here, I am Waswa and this is where we break down electrical and control systems into simple, hands-on and real-world lessons. So go ahead and hit that subscribe button and don't forget to turn on the notification bell so you never miss a video that could boost your skills. Have you ever wondered what happens when the grid power becomes unstable and how we catch it before disaster strikes? That is where this smart device comes in, the ABB-CM UFD M31. So you may ask, what is the primary function of this device? Well, it is designed to disconnect generators or inverters from the grid whenever the grid is unstable outside the allowed parameters. Now what does that help? So it basically ensures grid stability and safety of personnel and equipment. So we have talked of outside the allowed parameters. What do we mean? So this monitoring relay has key protection parameters and let us look at them. 1. It monitors voltage either under or over. It monitors rate of change of frequency and it also monitors voltage imbalance plus loss of mains, or what we call islanding detection. Where does this kind of relay is applied or used? So it is used in solar PV systems on grid, and it can also be used in wind turbines. It can also be used in battery energy storage systems, as well as it can be used in combined heat and power units. Let us look at the terminal description of this relay. I have broken down these terminals into 4 sections. The first one is control supply, output relays, feedback or control inputs, and lastly, the grid measurements. So let us look at one by one. So the control supply. So under this we have A1 and A2, and this powers the relay logic. It ranges from 24 volts AC to 240 volts AC or DC. Second one, we have the output relays. Now these are single pole double throw in nature, and these terminal points include 11, 12 and 14, and that represents relay 1, which is used for disconnecting grid. And then we have terminal 21, 22 and 24, which represents relay RR2 or the second relay, which often is a redundant backup or it is a second switching contact. Then we have terminal 31, 32 and 34. It still falls under the output relay, which represents the third relay or RR3, which is used for signaling events or driving circuit breaker motor closure synchronization. And those relays, RR1, RR2 and RR3, they have a common, and then the NC and then the NO. Then we proceed to the feedback or control inputs. Here we have terminals Y1, Y0, Y2 and Y3. So it is connected in a way that Y1 and Y0 monitors feedback for relay RR1 section switch, and then Y2 and Y0 monitors feedback for the second relay, that is RR2 section switch. And then Y3 and 0, it is an optional remote trip unit, or it can be used to suppress vector shift detection, and that depends on the configuration. Then lastly we have L1, L2, L3 and neutral, and that is used for measurement of 3-phase grid voltage, either line to line or line to neutral, and that depends on the configuration. Then we have the front panel screen and keypad. So under the front panel screen, we have the LDC display, and now this shows the grid values, the voltage, frequency, fault messages, thresholds, delay timers and event history. We also have LED indicators, and that is U/T. It can be seen, you can see it. So that is a green LED, and that shows that control voltage is present or timing. Then we have F, and that is red LED. So whenever you have that indication, it represents a fault active. Then we have RX/TX, and that is a yellow LED, which represents or indicates a Modbus connection activity. Then we have the navigation keys. Under that you can see we have escape button, ESC, which returns to previous menu or cancel during the configuration. Then we have the up and down arrows that are used to scroll through the menu items or adjust values. Then we have the OK button, which selects or confirms the parameters. In the next video, we shall see how this grid monitoring relay can be wired and used in control systems. Thank you.